Today's lesson is 11.3, Geometric Sequences in Series. How are geometric and arithmetic equations alike and different? So here's some notes that we need to copy down. The equation for an geometric sequence. And then we talk about geometric means as well. And then we also talk about the summation of geometric means. So they've got individual formulas there that you'll want to write down. Okay, let's take a look at this one. If our first number is -3 and our ratio is 2, what would be the sixth term? Okay, this one is easy enough that we could just write out 6 lines, 1, 2, 3, 4, 5, 6, and start with -3, and times everything by -2. So that would be 6, -12, +24, -48, and then 96. But if it wasn't so easy to just list out all the number, if we were looking for the 100th number, we would want to use this formula. So let's make sure we know how to do this as well. So a sub n is going to be our first number, which is -3, times r, which was -2, raised to what number are we looking for? The 6 minus 1. Now when you calculate that, don't do 6 minus 1, do 5. So you go 3 times -2, and in your calculator, you'll need parentheses, raised to 5. And you get a sub n equals 96. Okay, how about this one? How do you find the nth term? So this is for any number. So again, we go back to that equation. A sub n is going to be our first term, 5, and then our ratio, what are we doing from 5 to 10, and then 10 to 20, times that by 2. And then raised to n minus 1. We don't know what n is, but we'll just leave it like that. And that's as far as we can take that equation. So that's as much as we can do. We're done. How about this one? This one we're not given the first term in the sequence. Okay, so what we're going to have to do is find the first term by either working backwards or we can plug them into the equations. So let's use the equation first. So a sub n is 4. Don't know what a sub 1 is. Our ratio is 3 raised to, what term were we given? We were given the fifth term. So let's calculate this part right here. So that's 3 raised to the 4th. Use your calculator for that. 4 equals a sub 1 times 81. Divide both sides by 81. And you get a itty bitty decimal. So maybe we should leave it as a fraction instead. So 4 a sub 1 is 4 over 81. So then we can plug that in. A sub n equals 4 over 81, 3 raised to n minus 1. Okay, if you didn't want to use the formula, since it's only the fifth term, we could write this out, 1, 2, 3, 4, 5. And we put 4 there. And we would multiply to continue on by 3. So to work backwards, we undo it and we divide by 3. So this is going to be 4 divided by 3, which is 4/3. Well, 4/3 divided by 3 is going to be 4/9. 4/9 divided by 3. You'll notice the denominator just keeps getting multiplied by 3. 4/27. 4/81. So that would be another way to figure out our first term. But this right here is our answer. Find 3 geometric means between those two numbers. Okay, it's kind of like what we were doing with arithmetic means. We write out the numbers, leave 3 spaces, and then the last number. Okay, when we were doing arithmetic, we would subtract them and then divide by how many there are. But geometric is raised to another level. If we're talking about the PEMDAS, please excuse my dear Aunt Sally. So what we were doing arithmetic sequences, we were adding and then multiplying. We have to raise to another level. So we're going to start multiplying and then we have to do something with exponents. Okay, so this one, and we're actually not multiply, we're going to divide. 49.92 divided by 3.12. And you get 16. And now how many spaces does that have to be multiplied along? 1, 2, 3, 4. So what we're going to do is we're going to raise that to the 1/4 power, or take the 4th root of that. And so that comes out to be 2. So really what we're doing is multiplying everything by 2. So 3.12 times 2 is 6.24. Times that answer by 2, 12.48. Times that answer by 2, 24.96. And then again, like we did with arithmetics, check it again, times it by 2 again, and it does equal that number, so we know that we did them right. So the 3 arithmetic means are right there. How about this one? Julian hears a song by a new band, or Julian. He emails a link for the band's website to 5 of his friends. They each forward the link to 5 of their friends. The link is forwarded again to the same pattern. How many people will receive the email link on the 6th round of email? Okay, so the first round of emails had how many people? 5 people of his friends. Okay, so that's the first one. Second, third, fourth, fifth, sixth. Sometimes it's helpful to write out the 6 lines so that you know where you need to stop. Okay, so each of those is going to send it to 5 more people. So that's 25. And then each of those is going to send it to 5 more. Times 5 again. And then times 5 again. Times 5 again. And times 5 again. So that was how many people are going to receive it on the 6th round. That's our answer. But how many people total would it be if we did that? What we would do is we would just add them all together. There are formulas that we can use, but since it's such a small sequence, we can just add them together. So as I type them all in and add it all together, it would be 19,530 would be our total. And then we have the sigma notation again. Okay, so again, we have to list out from the first to the last, or put it to the 12th. We're going to put the numbers 1 through 12 into this function, and then add up that list. So the first time, we're going to do 3 times 2 raised to 1 minus 1. Well, that's 3 times 2 raised to 0, so that's going to just be 3, because 2 raised to 0 is 1. So 3 times 1 is 3. Okay, then I'm going to do 2. 3 times 2 raised to 2 minus 1. Well, that's really raised to the 1 power. So 3 times 2 is 6. 3. 3 times 2 raised to 3 minus 1. That's really squared. So 3 times 4 is 12. Fourth one. Starting to see a pattern here, hopefully. 4 minus 1, or cubed. 2 cubed is 8 times 3 is 24. So the fifth one, if we look at our pattern, they're just doubling. So 24 times 2 is 48. 6 would be 96. And then 7 is going to be 192. 8 is 384. 9 is going to be 768. 10, 1536. 11, 3072. And 12, 6144. Now we need to sum those all up. Now that is a lot of adding and a lot of room for error. So I wonder if we wouldn't be better using one of our summation formulas. So if we look at this, we now know the first and the last term, and we know every term in between. So we could use either one. Let's just pick the first one. So our first term was 3 minus 3. What was our ratio? We were multiplying it by 2 every time. And what term did we find? The 12th term, divided by 1 minus our ratio. Okay, so let's calculate the top. And you can just type that in. 3 minus 3 times 2 raised to the 12th. Negative 12285. Divide that by negative 1, and so that's 12,285. So that might be just a little bit quicker than trying to add them all up and possibly making a mistake as you add them up in your calculator. Okay, let's try another one. So this time I'm going to have the sum is of 8 items is 765. There are 8 items and their ratio is 2. So I don't have the first term. That's what I need to find. I think we don't know the last term. So it looks like we're going to need to use that first formula. So we type in 765 is our S sub n equals a sub 1 minus a sub 1. What's our ratio? 2 raised to the n. How many numbers do we have? 8. Over 1 minus 2. Okay, how are we going to solve this? Well, let's first of all simplify these two parts. So 765 equals a sub 1 minus, what's 2 to the 8th? 256 a sub 1. We usually see the number in front of the variable. We got negative 1 here. Okay, I could put this over 1 and cross multiply. And so I would get negative 765 equals 1 times that. But also, I can combine the top two terms together because 1 minus 256 would be negative 255 a sub 1. Divide both sides by that. And a sub 1 ends up being 3. Okay, that's the end of the lesson, so you can go ahead and write questions and summaries.